All right, welcome everybody. So in the next couple of videos, we are going to define what the inverse of a matrix is, talk about different ways that we can find these inverses and how we might be able to use them to solve systems of linear equations. So before talking about the inverse of a matrix, let's just start with something more familiar to us, which is the inverse of a function which is going from R to R. So imagine we're in a pre-calculus or a calculus class, and we're just talking about functions of real numbers. So if f is a function, then its inverse function, we denote f with a superscript of a -1. So this -1 here denotes inverse of f, not the reciprocal of f. Just be really careful about that notation. So the inverse function f to the -1, is a function that undoes the operation of f. So we plug a number x into the function f, it does something, out comes another output. If I apply f inverse to that output, it should undo what f just did and then tell me what was the original thing that we first plugged into f. So saying that more succinctly in math notation, what we're saying is that for any value x that's in the domain of function f, if I plug x into f and then I apply f inverse, it should undo the first operation and out comes x, the number that we started with. And we want to make sure that not only is f inverse the inverse of function f, but vice versa. F should be the inverse of f inverse. So in other words, we want to check this composition both ways. If I plug, so for any number y that happens to be in the domain of the inverse of f, if I plug y into the inverse of f and then evaluate that output at f, we should undo each other and get back the original value that we first plugged into the inverse. So let's take a look at a couple of examples to illustrate how functions and their inverse are related to each other. So for example, if we take a function f of x, which is equal to 2x, then its inverse would be the opposite operation. So if f, this function f, is saying take a number and multiply it by 2, well, what would undo that operation would be division by 2. So the inverse function would be 1/2 x. And so if we first multiply by 2 and then follow that by division by 2, we'll get back the original number. And if we first divide by 2 and then multiply by 2, we'll get back the same number. So that is checking these two conditions. Another example, which involves a couple of operations, would be, well, let's consider the function f of x, which is x divided by 5 minus 7. And here it's the inverse of this function would be x, the quantity x plus 7 times 5. And you can verify composing, doing first f and then f inverse will undo each other. Going first f inverse and then f would also undo each other. And how I tell my students that are first learning about functions and inverse functions how to find inverses is we can take a look at the first function f over here, and it's telling us to do a couple of operations in a certain order. So it's saying take a number x and let's first multiply by 5. And then secondly, we are going to subtract 7. And so if I want to undo those operations when it comes to the inverse, we're going to do these in the reverse order. So if the last thing I did was subtract 7 for the inverse, the very first thing I'm going to do is the opposite operation, which is add 7. And then I do the next operation, but the opposite. So if the operation that we first did was multiply by 5, then I'm going to do a second operation, which is going to be divide by 5. So to undo subtraction, we do addition. And to undo multiplication, we do division. And that's where this inverse function comes from. We first add 7 to x, and then we multiply that result by 5. So one key observation here, pretty much the only one that we're going to need to be able to find inverse matrices, is that note here, to find an inverse function, we do the exact opposite operations in the reverse order. So that's the same approach we're going to take with matrices. We're really not changing the definition or how we find inverses.